The microphone is on? Yeah? Okay, very good. Yeah, the microphone seems to be working even more than yesterday. So, can you put it down a little bit? Thanks. Any better? Yeah. And I know, so in the course of a tutorial, usually I get carried away by the topic, and I tend to speak louder sometimes. So if it becomes unbearable, please make me some signs to calm down. Okay, that's good. Right, so today we're going to do two things. So first, I want to talk about conditional obligations, because they're a bit tricky. And as I want to convince you at the beginning, this is something that standard Deontic logic do not handle very well, at least in the obvious way to handle conditional obligations. That's going to be the first part. And in the second part, I will discuss some more recent work on how to use something called fixed point logic to model some view about our norms or obligation are justified, right? How do you explain that this is actually what you should do or that what you're allowed to do? Okay, and for that I'll draw from some influential philosophical proposal on the justification of norm, and you'll see why I draw from them, because for a logician they're fun, they're a bit recursive. Okay. One thing I should mention regarding to neighborhood semantics, there was a couple of questions about that yesterday after the tutorial, is a result by Kracht and Volter showing that actually you can simulate non-normal modality, any non-normal modality that you want, using combinations of different normal modalities, okay? And the intuition behind that is this alternative way to spell out the semantics that I presented you yesterday. You remember the semantics for neighborhood semantics was there is a set in the neighborhood such that this set is exactly the extension of the formula, right? Well, what you do when you simulate, you have a diamond that points to set, right? And you say there is a set, and then you have a box that talks about the elements of the set, right? And so your neighborhood condition becomes a diamond box. Okay, so that's how you do it in the basic case. So neighborhood semantic is great, but if you really dislike it, you can actually stay normal in a way and keep doing non-normal modal logic, but then you have to equip yourself with more modalities. Yeah? I
actually wanted to ask you one question about the neighborhood.
Yeah.
Was it assumed that the points will belong to their neighborhood? Was it assumed that the point whose neighborhood you are considering should belong to that, essentially, or any collection of sets satisfying certain properties?
I'm not sure if I understand your question right. So you can take, it's not as in topology, so in neighborhood semantic, where you have a given set of open sets, right? So you can take any set you want and construct a neighborhood function.
Yes, in topology, you would have the neighborhood, if you take a neighborhood of a point, X belongs.
No, it's not. Yeah, thanks, right? It's not. So it's not as in topology where you define the neighborhood of a point as the open sets around that point. That's a special case, right? In neighborhood semantic, you can have any list you want, right? And the actual state from which you check the neighborhood can be an element of some of them, on all of them, or of none of them. It's really anything goes, right? Okay, good. So conditional obligation. So you remember I mentioned conditional obligation yesterday in the first part when I presented the distinction between wide scope and narrow scope. Okay, so you remember a narrow scope obligation, conditional obligation is one in which the obligation operator is in the consequent, right? So if you made a promise, you ought to keep them, right? And then the ought is on the consequent. A wide scope conditional obligation is one where the ought operates on the whole implication. So it ought to be that if you keep your promise, If you make a promise, you keep it, right? Okay, so that's the distinction. So this is going to be useful. So let's consider the following example. So suppose there's a party tonight on, I think this is Marina Beach here in Chennai, right? And suppose the following is the case. You ought to go to the party, okay? Say you promised to a friend that you would go, or this is the party of the century, or whatever reasons you want, right? You ought to be there, okay? Now, the following two statements are conditional obligations. So, if you don't go, you ought to say that you're not going, right? Okay, we assume that. Okay, let's assume so out of politeness, right? So especially if the first obligation comes out of a promise to a friend, right? If you break your promise, at least tell your friend that you're not going, because your friend will not wait for you indefinitely. The second one is, well, I phrase it as a wide scope, but we'll see it doesn't make a difference in saving the situation. But the idea is that, well, if you go, of course, you should not say that you're not going, right? Okay, because you're actually going, right? So there's no point of saying that, right? Okay. So that's the normative situation you're in, right? So you have this all-out obligation because you promised to go to the party, say, and you have these two conditional obligations. If you don't go, you should say that you're not going, and if you go, you should not say that you're not going. Right? But in fact, you're not going, okay? So you're actually not going to the party. Now, this example is known as Chisholm's paradox, or the contrary to duty paradox. Right? It's a situation where it seems what you're doing is actually contrary to your duty, right? And now we want to go, so your duty is to go to the party, and we want to know what do you ought to do, okay? Now, the intuition that many philosophers have, and maybe you have already, is that all these statements, right, should or are in a way independent, right? So it could be that I'm not going, right? It doesn't have any influence on whether I ought to go or not, right? Okay, and these two as well, right? So I ought to go to the party, and it might be the case that if I ought to, I should say that I'm going, but I shouldn't. It could as well be the case that if I ought to, I shouldn't not say that I'm not going, etc. Right? So that these four statements here should be somehow independent. Okay? But now let's see how we could formalize them in SDL. So one first proposal, right, is that the following is true. So you ought to go. That's the first statement, right? Okay. Now the second one was saying if you don't go, then you ought to tell that you're not going. Okay, right? That's the second step. The third one I'll write now is wide scope as I did, but we'll see many variation of it, right? It ought to be the case that if you go, you don't tell, right? Where here is tell that you're not going, right? Okay, but let's not multiply negations. So that's the third statement, right? And the fourth one is you are not going, right? Simply, okay? Now, in SDL, this is an inconsistent set of formula, right? Anyone sees that? Okay. And the trick is that because of K, right, you can distribute this O over this implication, right? But once you've done that, then by modus ponens on this one, right, you conclude that you ought not to tell, right? But then you use modus ponens on this one to conclude that you ought to tell. But we've seen that in K, normative conflicts are excluded, right? Okay, so this is inconsistent in K, right? So I told you before, the intuition is that these things are independent, but also that these things are consistent. It's perfectly possible to be in that situation, right? So if you want to model this situation in K, this is not what you should do, okay? Right. Now I'm just going to show you one variation of it. So of course, this one you might try to do is change the scope of these obligations, right? Okay. But you see what's going to happen, right? So already, so if you, for example, let's erase this. So if you put both of them in narrow scope, you have this. Right. Well, now this is not satisfying either. Why is that? Because now the third obligation here is a consequence of this one, right? Okay, so if not go is, so if it's not the case that you go, then the implication, if you go, you ought not to tell, is just true trivially, right? Because the antecedent is false, right? And that's not satisfying either, right? Because you do not want, you want the obligation that tells you what to do if you go, right? To be independent of the fact whether you're going or not, right? Okay, and that's not satisfying here, right? And if you put both of them in wide scope, right, you also lose independence because of this one, right? Okay, because of you ought to go, right? Okay. So the conclusion that many philosophers have drawn is that if you accept the intuition that these four statements should be somehow independent and consistent, right? Okay, then SDL is somehow not the place to look for to analyze this pattern of conditional obligation, right? So, and this is a lesson that has been taken in the literature quite early in the history of Deontic logic, that conditional obligations are tricky, okay, and they do not behave like obligations of conditional, neither in wide scope or in narrow scope. But if you're familiar with the literature on conditional, this is not something that should come as a huge surprise, right? We know very well that there are many conditionals that do not behave like material implication, counterfactual conditional, or if you're doing probability theory, you know that this classical triviality result that probability of conditionals cannot be the same as conditional probability, right? So you have to do something else, right? You have to have a theory which treats obligations, conditional obligations, differently. And this is what we will do now. I will present you in the first part today something that's called default logic. So there is a lot of different approach to conditional obligations. I'm presenting you this one because it's slightly different than what we've seen so far. We've seen a lot of modal logic so far. I thought it would be refreshing to see something different. And I will just sketch how it works through a couple of examples, but I've passed on to Sujata and Ram a paper by Jeff Horty where I will draw mainly form where he explains how this works in detail, right? So you can have a look at that. Okay, so that's the program for today. Now, I want to hammer even more, so I'm sure now you're totally convinced that SDL is not handling conditional obligation well, right? But just in case, let me try to hammer the point a bit more. I'll give you two more reasons why we need to look for other places for handling conditional obligation. So now we've seen that they're not handling it so well. They are also conflict intolerant. SDL is just conflict intolerant, right? We've seen that, right? So it is not, so if it ought to be the case that you go, and it ought to be the case that you don't go, right? Then it ought to be that everything, right? Okay, so it's just the thing trivialized, or it's, if you accept O implies P, this is just a plain, so.
So how to prove that in this?
Right, how to prove this, right? Well, we've seen that this is a theorem of SDL. Right? So that's just a rewriting of O implies P, right? So yesterday I mentioned that quickly, right? Then this just follows, right? I mean, this is just the negation of that, right? So SDL is just conflict intolerant. And what I mean by a conflict tolerant logic, you'll see why later on why it relates to conditional obligation. But a conflict tolerant logic would be one in which you could have this without having a contradiction, but also in which you could have a conflict like that without ending in the situation in which you ought to do the impossible, right? So you can have a logic that do not explode when you have normative conflict, but that will conclude that if you ought to go and you ought not to go, then you ought to do the impossible thing, right? And we will see that any logic that has an unrestricted form of closure on their intersection, of course, will get you that, right? Because if you ought to go and you ought not to go, and it's closed on their intersection, then you ought to go and not to go, right? And that's a contradiction, right? So you have to restrict closure on their intersection, and we'll see that the logic for conditional obligation that I will present you in one of its variations is actually conflict tolerant in a very nice way. Now, finally, I want to draw your attention to the fact that conditional obligations also are defeasible, right? What does that mean by defeasible is that if you add condition to the premises, sometimes the obligation fails. So if I promise to go to the party, right, then I ought to go, right? But it's everything else being equal or everything else being normal obligation, right? If I promise to go to the party, but I got a phone call from a friend who's very ill and he needs my help, right? Then it seems I'm not obligated to go to the party anymore. What I should do is go help my friend, right? So this has priority, right? Okay, but of course, material implication is monotonic in the antecedent, right? So if let's put it in narrow scope, if given P, I ought to Q, then given P and R, I definitely ought to Q as well, right? Okay, so this is so the second line here follow from the first, right? This has nothing to do with Deontic logic. This is a property of material implication, right? So that's a feature of conditional obligation on top of this Chisholm example that I told you before, which is not handled well in Deontic logic or in standard Deontic logic. Okay, so this is the feasibility aspect. Okay, so. And that's not a surprise that a huge part of the literature on conditional obligation has been developed in the theory of non-monotonic reasoning, because this is essentially where the theory of implications that are not monotonic or that are defeasible has been developed. So again, I'm giving you reference to this handbook of Deontic logic. I should ask the host to give me some sponsorship but I'll do other, actually, college publication should pay me. So, because the third book is also a book by college publication. So, if you're interested in theory of non-monotonic reasoning in general, and with some nice example to Deontic logic, I strongly recommend you David Makinson, Bridges from Classical to Non-Monotonic Logic, from which there's sort of a 100-page extract / summary, which is available online, free for download, I think on his webpage, if I remember right. But if you look for it, you will find it, right? So, so you don't have to buy the book. You can find, I mean, the book is great because there's exercise and a bit more explanation, but the concise 100-page summary is actually very good as well. Yeah?
Can I add that the book should be recommended even if you're not interested in non-monotonic reasoning?
Yes, that's a.
I mean, I would say it's essential reading for any logic and AI.
Yes, definitely, right. It's an excellent book. You also learn a lot about even classical logic. You thought you know about classical logic. I thought I knew, and then I read the book and I realized I didn't. So it's a great book, yeah. And so Mankingson, I'm mentioning Mankingson here because I will actually present you default logic, which is one particular case of non-monotonic logic, as Horty presents it in his recent book, Reasons as Default, okay? But that's just one type of non-monotonic logic, one which is presented in the book, but there's other types that are that exist, and Makinson presents them and relates them, actually, okay? And in particular, there's one time if you're more sort of modal logician type of person and thinks about models with accessibility relation, there's a natural also way to model non-monotonic reasoning using that, and Makinson is actually showing it in the book. Okay, but our focus will be the book that's in the center, Horty's Reasons as Default. which appeared in 2011. And again, so the paper that I passed that you will probably receive as reading material is an open access paper in which Ordi sort of presents the outline of the book. The paper is a bit older, but you get the gist of the argument in that paper. Good. All right. So I will present you default logic through a number of examples. Okay. I'm not going to go into detail, just explain you how things work. And I want to give you two examples, one which talks about reason to believe, or what you should believe, and one which is about reason for action, what you should do. Okay. Now, sometimes you have conflicting evidence, and politicians are good at providing them, right? Evidence for one thing and its contrary. So here's Richard Nixon. And it's a classical example of in non-monotonic logic, but it's very applicable here. So the question we're going to ask ourselves here is whether Nixon was a pacifist. Okay, right? That's the question we're asking ourselves. Whether we should believe that Nixon is a pacifist. Okay, maybe you're about to vote, right? And that's a very important issue for you, right? And whether the next president is going to be pacifist, right? Now, you have two default rules that can help you reason in this case, right? The first one is actually that Republicans tend not to be pacifist, okay? And when something entails a negation of something else, I will write it down with an arrow with a cross, right? Okay, so Republicans usually are not pacifists, right? This is a generalization, but in recent experience, we've seen that, right? Okay. Now, our other rule is that actually Quakers are pacifists, right? It's very important for them. Okay. Now, as it happened, Nixon was both a Quaker and a pacifist, and a Republican. Okay, right? So, what should you believe about Nixon? So this structure presents us with a set of what's called default inference rule, right? Especially the top one, right? The down one, we can, since we know that Nixon is a Republican and Nixon is a Quaker, those will not be put into question. But the two top arrow, which I will note delta 1 and delta 2, right? Are two default rules. Usually Republicans are not pacifist, and usually Quakers are pacifist. And the question is, what should you believe, right? What should you think about Nixon's view on war? I will not answer this question, but I will show you various ways to answer it, okay? But first, let's go, so we're going to keep this example in mind, and that's the example, because of its shape, it's often called a Nixon diamond, so you've probably seen that example before. Okay, so the next example is actually, so yesterday I was pressed on where are the multi-agents. Well, here's one, okay, but not in the sense that you're interacting, but you made actually promise to two people. So suppose you have these two completely undistinguishable twins, right? So it's an old movie, so I guess many of you were maybe not even born when the movie was there. So I realize more and more, like, quote movies that most of my students haven't heard of, right? Well, you don't have to watch this one, really. It's not worth it. But we're talking about old movies and Republicans, so here's another one. So you made two promises, right? You didn't realize, and you promised to twin 1 to go to restaurant with that person tonight, and you promised to twin 2 to go to the restaurant with that person tonight as well, okay? So let's write a couple of defaults to describe this situation, right? So you have, so if you promise to twin 1, then normally you ought to go for dinner with twin 1. Okay, that's the situation you're in. And if you go for dinner with twin 1, you should make a reservation in restaurant 1, the restaurant that you were supposed to go to dinner with. Okay. Now the situation is exactly parallel for twin 2, right? Okay. So if you promise to twin 2 to go to dinner, then you should do that. and you should make a reservation. Okay, that's the situation you're in. But the problem is that, and now it's not a default rule, this is a hard fact, right? You cannot do that simultaneously, right? Let's say, like in the movies, the two twins, they don't like each other very much, at least at the beginning. Of course, they're all a big family in the end. But let's say you're at the beginning of the movie, right? And going for dinner with twin 1 excludes, as a matter of fact, going with dinner with twin 2, right? And I'll write it with a double arrow when it's a matter of fact, right? Okay, so you cannot do both things at the same time, right? But now suppose you're in a situation when you made both promise, right? What should you do? Okay, so that's a typical situation in which you might think you're in a situation of a normative conflict, right? Because you have intuitively conflicting obligation. On the basis of your promise to twin 1, you ought to go to dinner for that person, and you ought to take the means to do that, namely make a reservation, and similarly on the basis of your promise to twin 2. Okay. Now, default logic provides you various ways to resolve or to answer the question, what should you do? What are the obligations that bear on you in this situation? So, to put it a little bit formally, a default theory, right, we'll call it that's a triple, right? W, D, and this relation. So, W here will thus be, well, it's sort of curly or calligraphic W, right? Okay, because it's not a set of possible worlds. It will be a set of formula, right, that you take for granted, right? A set of facts that you take for granted. For example, that you made these promise, or that Nixon is a pacifist, is a Republican, and so on and so forth. Okay, so W is a set, or usually finite, of formula. Yeah, exactly. These are background formulas, things that are fixed in your background. So if you're familiar with other non-monotonic logic, this is your knowledge base, right? This is where you start with.
And language is
propositional PQR, right? Okay, so there's no Deontic operator, no modality. It's just a basic propositional language. Okay, right? So in our case, for example, right, language contains these P's, these D's, and these R's, right? Things about Republicans and Quakers, and so on. Right? Okay, so rather simple. Now, D is the set of default rules that are available to you. Okay, so in this example, for instance, right, there are at least 4 default rules, and you might think of these as hard fact, right? This double arrows. So you have D1 and D2 here on this side, and D3 and D4 here. Right? Okay, so these are your inference ticket, right, from premise to conclusion. And it's important to notice, and that's why I sort of refrain to write them as with arrows in the implication says these are not material implication, right? They behave very differently. For instance, right, default can be non-monotonic, right? They're not necessarily monotonic. It's perfectly fine to have a default that says if A, B, but if A, C, then not B, right? It's perfectly fine to have that in your theory, so this is not material implication. And as we'll see, default do not contrapose either, right? So if I had a default that says if A and B, right, and I have A, I can conclude B, but if I have a default that says infer B in case of A, right, and I have not B, I cannot infer not A, right? Yeah.
When you use the word rules,
yeah,
they essentially mean some conditions. Is it so?
Yeah, they behave much more like these conditional, but this is not a material conditional.
No, not material, but it is a conditional.
Yeah, it is a sort of conditional.
Simply a well-formed formula. It's not a derivation.
No, it's not yes, right. It's not a derivation. There's no proof system in the background. This is I think the word inference ticket is actually describing what it is very well.
Because I raised this issue because sometimes we say modus ponens as a rule.
Yeah.
These are transformation rules.
Yeah.
and conditionals are conditionals.
Yeah, exactly. No, that's right.
There is a conflict again, in computer science community, by rules they mean conditionals.
Right.
So here you are using rules in the sense of
conditional. Yes, that's very true. Yeah, yeah. Not in terms of inference rules. So if you use, for example, to proof theory or to sequence calculus, right? This is not a rule in this sense, right? Definitely. Okay, so D is your set of default. Whoops. Okay. And this, I'll show you to you later on what to do with this. This is a priority relation between defaults, okay? And the reason for that is that, for example, in the Nixon case, right, you might think that maybe religious beliefs take priority over political allegiance, right? Or the other way around. Maybe you think political allegiance will usually take priority over religious belief, right? And that in the presence of a conflict like this one, right, you should prioritize, right? So the default that says if you're a Quaker, you're a pacifist, will have higher priority than the default that you have that says if you're a Republican, you are not a pacifist, okay? So you can have prioritized default, but here, in treating this example, I will actually take them as no priority, right? So to generate conflict. So, but the full theory so it's a priority relation over D, right? And this relation is usually assumed to be transitive, right? Asymmetric and irreflexive, right? Okay. And usually complete, right? Okay, so it's usually in order, but it doesn't have to, right? Yeah.
So default is just a pair of formulas.
Yeah, a default, exactly, right? The default is a pair of formula, right? So you can think of these arrows here as default, right? So D1, R1, right? Okay. And the intuitive interpretation is if you have D1, you're allowed to infer, right? It's an inference ticket, right? Okay, R1. Okay. Now we're going to see how this proceeds to, how this inference mechanism proceed, how you compute what you ought to do or you ought to believe in the sort of default theory. And for that, we need to build our way to the notion of a binding default. Okay. And what do you use this idea of binding default? What I can tell you right now is the intuition, and you'll see it built and come back to it afterwards, is that defaults provide you sort of prima facie reason to do or to believe something. Okay, so in the Nixon case, for example, the default that if you're a Republican, you're not a pacifist, it's a prima facie reason to disbelieve that the person is a pacifist, learning that the person is a Republican, but it's prima facie because it could be overruled if you have defaults with other priorities, which are also in force in a given situation, right? And that's so what we want to know is which defaults are binding, which reasons are the one you will use in your reasoning. That's the idea. Okay, so the basic idea is to start with a scenario, S, right, here, which will be a subset of your set of defaults, okay? They will be the defaults that you accept, right, okay? And now we want to compute something that's called a proper scenario, which consists of binding defaults, okay? But for that, we need to build our way slowly. So we're going to say that given a scenario S, a default is triggered, right, so these are the defaults you accept, right, okay? So we take them to be already triggered, but I mean, usually when you start your computation, you start with an empty scenario, right? Okay. So you start with your knowledge base. You look whether this knowledge base entails, so forget about the conclusion here for now. You just look here, and you look which of these knowledge base entail the premises of some defaults you have, right? Okay. And these will be those that are triggered in the particular scenario. Okay. So essentially, right, where you can use your inference ticket because the premise are actually entailed by your knowledge base. And you see this is entail, right? So we're saying more than just they have to be there, right? If there are logical consequences of what's in your knowledge base, then that's okay, right? So these default theories will be closed under logical consequence. whoops, okay, so this won't build up too much, but let's just look at this, right? A default in a scenario is conflicted, right? Well, this is a bit of a complicated way to say something simple, namely, a default is conflicted if there's another default in, or if your knowledge base entail the negation of the conclusion of that default. Okay, so for example, in Nixon case, right, if I know that Nixon is a Quaker, right, then the default that if you're a Republican, you're not a pacifist is conflicted, right, because if I have a Quaker, I can conclude that he's a pacifist and this is a conflict. Okay. Now, defaults can be conflicted, but they can also be defeated, right? And this is using the priority relation. So a default is defeated if it's conflicted by a triggered default with a higher priority. So the formal definition is a bit complex, but the intuitive idea is just this, right? There's a default which is triggered in the current scenario, which conflicts the default that you have. It doesn't mean that you have to throw it away, but if the conflicting default has higher priority, yes, then this lower priority default is just defeated, right? That's the idea, okay? And a binding default, right, will just be one which is triggered, unconflicted, and undefeated, okay? So no contradiction. Okay. So the idea here now is to start with a default theory, right, and compute the binding defaults in that theory, right? They will often be subsets of the full default theory because some of them will be conflicting, there will be defeating relations, right? And now that we have that, we can reapply, wonder whether in this new theory, the one that contains only the binding defaults, whether there are now new conflicts or, so there might be new things that are triggered because now I have new conclusions that I can add, right? And whether new things are conflicted, new things are defeated, and I compute the new binding default and I go on, right? And the idea of a proper scenario, right? So let me write B of S, and you remember S is always a scenario based on a given default theory. It's just the binding scenarios in that theory, right? Well, a proper scenario is one which is a fixed point of this binding operation. Right? So a proper scenario is a scenario S such that S is equal to the binding scenarios in S. Okay. Now this is all abstract, so let's look at our couple of our examples again. Right. So let's start with this one. Right. So suppose we know that our knowledge base is just that. Well, usually you replace this thing with tautology, right? And you put just a tautology in your knowledge base. Now, if you do that, right, in a scenario where there's no default at the beginning, right, so if you start with S0 antiset given this theory, right, then you have these two things will be triggered, right? Then you have these two here, and you wonder in this new theory, are there new things trigger? Yes, these two above, but these two are conflicting, right? This is essentially what we were saying earlier, right? So actually, if you look at proper scenarios in this story, there are actually two proper scenarios, and you can check it yourself, but these are intuitively what you want. So that the two proper scenarios are S1, where you, so let's call this one, where just the default one is triggered, namely this one, and S2, just the default 2 up there, right? Okay. So these are the two proper scenarios, right? Either you conclude that he's a pacifist, or you conclude that he's not, right? Okay, these are the two scenarios. So two things you could believe on the basis of reasons that are binding, okay, not defeated by others, right? Okay. Now in this scenario we have the same story, right? Okay, namely that there are in this story, we have two proper scenarios. One in which D1 and D2 are triggered, and undefeated, and then you have the right column, D3 and delta 4. Yeah. Right. So the left branch or the right branch. Okay? That's good. So these are the things that you have sort of good reason to do or good reason to believe in your current situation. Okay? But now the question is, what should you do? Right? Okay? What are the obligations that bears on you in these situations? So in the Nixon case, right, what should you believe? In the twin case, what should you do? And there are two, on the market, there are two ways to think about it, two intuitive ways, and they give you actually very different result. The first one is what's called disjunctive or skeptical account, right? So you would say that you ought to A, right, if and only if A is a consequence of all, well, let me put it this way. Yeah. Let me write this one. So if A follows from, yeah, I didn't need this consequence relation, I'm sorry. So if A follows from all the proper scenarios that are in the actual context, okay, right? So in Nixon, for example, right, what should you believe about Nixon? Well, in the skeptical account, you should actually suspend belief, right? Because there's a proper scenario in which he's a pacifist and there's a proper scenario in which he's not, right? Okay? So what you should believe in this case is actually that well, he's either a pacifist or he's not, so that's not very informative, right? Okay? But that's the sort of skeptical or careful account, right? So you believe you ought to believe something if only if it follows in all the proper scenario, okay? So in the twin case, this is a bit more informative, right? Because it says what you should do is one of them, right? So you should either go to restaurant 1 with twin 1 or go to restaurant 2 with twin 2, right? Okay? Because it follows in this scenario you go and you reserve, and in this scenario you go with the other one and you reserve, right? Both of them entail the disjunction, right? So this will be true in both, right? So this is one. In this case, this is the only non-trivial thing that you should do. I say non-trivial because it's not a tautology, right? It could be that you go to neither of them, right? Okay? So what you should do in this case is go to either of the restaurant, but not more, okay? Now, of course, there's the obvious other alternative, the conflict account, right, okay, which says you ought to A if and only if, now let me write it properly, A follow from some S star proper scenario, okay? So you make an existential quantification here. Okay, and of course this is called a conflict account, not for nothing, right? Because in the twin case, for instance, right? Well, there's one proper scenario where I go to restaurant 1 and I make a reservation there with twin 1, and there's another one where I do the other one, the opposite thing. I go with twin 2 in restaurant 2 and I make a reservation, right? So the conflict account will tell you, well, in this case, you're in a normative conflict situation. You ought to go with twin 1 and you ought to go with twin 2. So you just place yourself in a more normatively very bad situation because whatever you do, you're going to violate some of your obligation, actually, right? It doesn't resolve. It just says, well, poor you. You put yourself in this case. Okay. Now, this conflict case, you might think, the reaction that many people have in the conflict case is that, well, because you made these different promises, somehow they cancel or something like that, right? So maybe there's a way to resolve that conflict. But there are a number of other examples in the literature which are supposed to trigger deeper intuition about the existence of normative conflicts. And the classical one is actually from the French existentialist philosopher, Jean-Paul Sartre, who has this case where a young man was, during wartime, right, and his country was attacked, and it was fully morally the correct thing to do was to go defend his country or defend his fellow citizen. But also his mother was ill, right? And on moral ground, he ought to stay at home and take care of his mother. So it seems in this case of the young soldier, it ought to be that he goes to defend his country, and it ought to be that he should stay with his mother, both of them on moral ground, right? And there's no reason to think that maybe one cancels the other. And since these are very important obligations, both of them, it's hard to think that there's really a priority in this case, right? Okay, so it seems it's supposed to be a case where if you're skeptical of moral conflict, at least you should say, well, in this case, at least I don't know what to do, right? Okay, so good. All right, so I want to finish this story about conflict with talking about what philosophers call agglomeration, but which is essentially closure under conjunction. So I mentioned if you have a logic which is conflict tolerant, you'd better give up that principle. Right? Because even though you might like normative conflict, most people dislike the idea that you ought to do the impossible thing, right? Okay? And if you have a logic which is conflict tolerant, that is where it's possible to have O phi and O not phi, right? If you have this unrestricted agglomeration principle or closure principle, then you will conclude that you ought to do the contradiction, and this is impossible, right? Okay? So if you have a conflict which is a logic which is conflict tolerant, you should give up that. And the conflict account that I just sketched you is actually conflict tolerant in this sense, right? Why is that? Because it says you ought to do something, right, if it's true in some of the proper scenario, right? Well, the conjunction is never going to be true in any of those scenarios, right? So for an ought A to be the case, did I say conjunction? The contradiction can never be true in any of these scenarios because all these scenarios are individually consistent, right? So you'll have a case here where you ought to go for dinner with twin 1 and you ought to go for dinner with twin 2, but it's not the case that you ought to go for dinner with both, right? Because there is no extension in which you ought to go for dinner with 1 and with 2 because by assumption it's impossible. So you have a case where actually agglomeration is restricted, right? And in a natural way because you say just in some extension, but these extensions are consistent object, right? Okay, so that's nice. But then you might think, how much agglomeration do we want, right? Do we want, okay, we don't want full agglomeration, but you might want to say, let's do consistent agglomeration, right? So if you ought to phi and you ought to psi, and phi and psi are consistent, right, with each other, then maybe you ought to do both, right? So that would be something that's called consistent agglomeration. Right? Okay, so that's this principle if phi and psi do not entail contradiction. Okay? Good? Well, even that is questionable, right? Okay? And that's the point of this example. Okay? Look at, so here we're in a situation where what you ought to do is go for dinner with twin 1 and reserve at restaurant 1, go for dinner with twin 2 and reserve at restaurant 2. Okay? Now, it's not the case that you ought to do these two things, right? Okay? But if you require consistent agglomeration, right? Okay? Actually, not only do you ought to go for dinner with twin 1 and reserve at restaurant 1, you actually ought to go for dinner with twin 1 and reserve at restaurant 2, right? Why is that? Because it's perfectly consistent to go for dinner at one place and reserve at the other place, right? It might cost you a bit of money if the restaurant asks you for a reservation fee, but it's not inconsistent, right? So if you accept consistent agglomeration, then you're bound to the conclusion that what you ought to do is actually this a bit weird thing that is go for dinner with 1 and reserve at both places, or go for dinner with 2 and reserve at both places. Yeah?
There is no direct path from this.
Very good, right? So this logic actually does not accept consistent agglomeration, right? okay, because there's no path, right? So there's no proper scenario in which you go from here to there or from here to there, right? So consistent agglomeration is a natural idea to say, oh, maybe that's what we want, but this case is actually showing you that that is not the case, right? You do not want consistent agglomeration. You want something even weaker than that. And this, the conflict account gives you precisely that, right? Or at least it doesn't even give you consistent agglomeration, precisely for the reason you give. Because there is no proper scenario in which I go for dinner with twin 1 and I book a table at restaurant 2, right? And vice versa for this one. Okay, so this is you're perfectly right, right? So consistent agglomeration is not valid in this, well, in the default, in the conflict account, right? Precisely because it's not necessarily the case that a proper scenario will contain all consistent, possibly consistent combination of actions or facts. Consistent in the logical sense of the word. Okay, so this is something which people like Horty, who's actually a fan of the conflict account, hammer over and over again, right? That when you have a conflict-tolerant logic, you have to be careful with agglomeration, and that actually this idea of replacing it with consistent agglomeration is a naive one, in the sense that if you, in the face of examples like that, you realize this is not what you want, and that the conflict account is actually behaving very well in this case because it gives you, it doesn't give you consistent agglomeration. Okay, so this is what I wanted to say. Now I want to conclude this part by just saying you that I haven't said much about the feasibility, right? Because I wanted to focus on the case of moral conflict in this. But of course, default logic is very good to talk about defeasible obligation as well, because if you have a default, as I say, from A to B, doesn't exclude at all that you have another default that says A and C, not B. And if you're interested to see how this works, please go to Makinson, right? This is explained in detail, in great detail. Now, I also want to make the connection. So for those of the mechanism that I've used here to talk about what you ought to do in the face of conditional obligation and or moral conflict, right, is a mechanism which is very akin to one that's been used in belief revision, right? And I want to emphasize again the common ancestor in the history of both these theories, namely Carlos Altura, right? Okay, so the work is done on law change, inspired or started up what became later on belief revision, and he kept doing also the Deontic logic on the side. And final point is that this study of conflicting obligation is one of the most active area right now in Deontic logic. And if you look, for example, there's a bit of a hype now on something that's called adaptive logic. You can Google it if you want. These are logic which are meant to deal in a slightly different way with conflicting obligation, but have very interesting dynamic proof theory. Okay, question before we take this non-existent break? Yeah.
So, consistent agglomeration, you don't take the time to take some other, like join scenarios or number scenarios.
Can you speak up a little bit, sorry?
Yeah, so instead of taking this by AND study as a agglomeration, you can take something like proper scenarios.
Exactly, exactly. Yeah, this is what's going on. Yeah. So, so to know what to agglomerate, right, it's not sufficient in this theory to look at what's consistent. You have to look at what proper scenarios you have at your disposal and look what's true in them, right? Okay. So of course, if there's one scenario in which phi is true and psi is true, because you take some sort of closure on the conjunction or on the logical consequence, then the conjunction will be also true, right? And on the conflict account, it will be the case that you ought to the conjunction, right? But that's because you're in one proper scenario. And the idea here is that that's one sort of reason, binding reason you have to do both. And since it's binding, you should do actually the conjunction of them, right? So you indeed, right? That's a good way to put it. You have to look at what proper scenarios are available to you. Yeah. Yeah.
You're not actually saying what one should do. So maybe you should just toss a coin and decide.
Yeah, that's interesting. That's interesting. So the conflict account indeed doesn't tell you what to do. It just describes the moral situation you're in, right? So in the case of the promise, right, it just tells you, well, poor you, right? Whatever you're going to do, you're going to violate some of your obligation, right? There's no way out for you, right? If you go with twin 1, you're going to violate your obligation to twin 2, and vice versa, right? Okay, that's. So the conflict account is indeed not a mechanism for resolution of conflict, right? But that's what these people, so Orty, for example, he goes at great lengths to argue that actually, indeed, on moral ground, sometimes there is no resolution, right? So morality does not tell you. It puts you in a situation of conflicts, and you're stuck there, right? So on moral ground, there's nothing you can do to resolve that conflict, right? Okay. Of course, you have to do something, right? But the conflict account will tell you whatever you do, you're going to do something wrong, right? Yeah.
So right now, this conflict account is really focusing on the morality issue. But what if we bring it in the ethics purview, within the purview of ethics?
Yeah. Yeah. That.
Let's take a legal account.
Yeah. Very good.
And there could be a possibility that you are stuck up in a situation where two legal foundations you are breaking off, and you have to somehow fulfill any one of them. So will the charges be pressed against you, or say you are breaking the law, going against the law? Yeah. So how does the state is supposed to come over with it?
Good. So actually, it's very good you're mentioning that for two reasons. The first one is indeed that Horty, for example, but other people in default logic, have used this account to analyze concrete types of legal reasoning, right? Because this sort of conflicting situation is much more naturally occurring in law because lawmakers are fallible persons, right? Sometimes they draw inconsistent texts of law, right? It happens, right?
Yeah, or a number of loopholes.
Exactly. Or, as you said, right, various of levels of law, right? Maybe the national law will contradict some principle in the local one, and so on, right? Or the Constitution would.
So, anyways, you are solving the scene behind the curtain. So, there's no matter of going into logic.
No, right? So the logic, this account will not tell you how to do that, right? It will flag the conflict, right? It will tell you, of course, I didn't tell you anything about priority, right? In many legal systems, you have some clause that says, if we find a loophole, the Constitution has precedence, as priority over the local law, for instance, right?
How is it associated with the multi-agent systems? Like, how this particular situation, this conflict issue, which is being just observed,
yeah,
not giving any solution to it, how is the multi-agent system benefited by this?
Well, I mean, I take it that, and there's various ways you can think about applying it in multi-agent system, but one obvious way is to think that maybe you have obligations that these default might apply to different persons, right? So you have one default applied to person 1, one default applied to person 2, right? And they conflict in the sense that maybe you cannot do both actions together, right? So in the current situation, then this person should buy the product, and that person should also buy the product, but they cannot buy them together, right? Well, the default logic will tell you there's various ways you can go at it, right? You can just say, well, it's too bad, right? So one of them will have his right violated, right? Or if you don't like that, right, you could go for the careful account and say, well, we should, I don't know, flip a coin, right? One of them is that won't be the careful account, right? Or
So anyway, we are going to mock the inability of your actions.
You what? Yeah.
You are going to the mock.
Yes, sure. But I mean, the disjunctive or skeptical account, right, is compatible, I guess, with your intuition here, that you would say, well, what you ought to do is sell the product to one of these two, right, not to anyone else, right, or throw it away, right? Now, you might have a resolution process, a tie-breaking rule, which is independent from that, right? Maybe as flipping a coin, right? Something like that. And this is perfectly compatible with the skeptical account, right? Because then you do not violate the obligation, right? Because what you ought to do is to sell with any of those, right? Okay. And the legitimacy of the tie-breaking procedure is something independent from that, right? It's not part of the logic, right? Yeah. Good. All right. So, nope. Okay. So we're having a blitz break again. And now we switch to the other part, okay? I talk about legitimacy, and I want to finish this tutorial by taking you into sort of more new ground, recent ground, work that I've been doing with colleagues in Munich about how to justify norms, because so far we only talked about norms that are in place, and we try to reason about them, right? The question we're going to ask now is under which condition is a norm valid or legitimate, okay? And that's an important question in ethics, of course, but also in legal theory, what you want to, where is the coercive power of the law legitimate and so on, right? This is a very important question. And what I'll do, I will sketch you a philosophical view about that, give you some mathematical tool to deal with that, and then wave my hand and point you at the paper into how we actually use these tools to deal with this philosophical view. Because I think the tools are interesting, and it's something it's interesting to know, and it's important to see how they can be applied to deontic logic. Okay? So the question we're going to write now is right and wrong, right? So when is something right or something wrong? Like this philosopher here was claiming we are right and we can logically prove it, right? So the question is, what does it mean that a certain thing is the right thing to do or a certain thing is the wrong thing to do? Of course, this is a fundamental question in ethics, right? Okay. And there's no surprise that a lot of ethicists are trying to answer this question. And one particular view of the justification of norm in contemporary ethics, it was called procedural justification, right? Is that a norm is justified if it survives some sort of test, right, or some sort of procedure, right? So you might have heard of discourse ethics, which has been, which Jürgen Habermas is a big proponent of. So discourse ethics says, roughly, right, that a norm is justified if it could be agreed on in some ideal speech situation, right, where people have long enough time to discuss, they don't coerce each other, they yield to the force of the better argument, and so on. And if a norm could pass this test, could be agreed upon at the end of this discussion, then for Habermas, the norm is justified. Okay? So it's a very deliberative view of the justification of norms. So how do we know that the norm is justified? We should sit down together and talk about it. Right? That's basically the idea. Now, the view I want to explore today is the one which is a bit more recent from Timothy Scanlon. This is Scanlon here, and this is from a book from 98, if I remember right. What We Owe to Each Other is a very important book in moral theory. And a bit of an anecdote. So Scanlon's first paper in philosophy was on Tarski's theory of truth, right? It's a very technical, logical paper. And then he turned to ethics. But he used to be a logician in his young days. So this is Scanlon here, and we're going to look at Scanlon's view on the justification of norm. That's going to be our target today. Okay? So this is a quote from What We Owe to Each Other, the book. Right? We're going to read with you slowly. So Scanlon says, when I ask myself what reason the fact that an action would be wrong provides me for not doing it, right? My answer is that such an action would be one that I could not justify to others on grounds that I could expect them to accept, right? So the idea here is that you ask yourself, why shouldn't I not do wrong things, right? Okay. So you're telling me something, this is wrong, don't do this, right? And you're asking why, right? Okay. And Scanlon says, well, one answer he's giving is that you could not justify it to others on ground that you could expect them to accept, right? Here's a ground that you should not expect, right? So why I'm telling you don't do this, right? And I'm telling you I'm going to need to steal $1 million from you, right? And you're telling me, I'm not happy with this, right? And I'm telling you, well, look, this is great, right? I'm going to be a millionaire afterward, right? Okay? Well, this is not a ground that I can expect you to accept, right? Okay? This is not the sort of reason that I can expect you reasonably to accept. So Scanlon says, on those that I would expect you to accept, if I can think I will convince you, then this will be a reason for me to do or not to do this thing. So he goes further. He said, this leads me to describe the subject matter of a judgment of right and wrong, right and wrong by saying that, and that's a crucial point. It's quite a mouthful, so take a deep breath. They are judgments about what would be permitted by principle that could not be reasonably rejected. It's not over. By people who were moved to find principle for the regulation of behavior of other, that others similarly motivated could not reject, right? Okay. Let's read this again. Okay. So when is something, well, let's start in the middle, right? When is something permitted, right? Which actions are permitted? These are those, right, that people who look for principle of regulation of behavior, right? They look for rules of conduct, right? Okay. That are motivated, these are principles that could not be rejected by people who are looking for what to do and are motivated to find these principles on the same ground as you. That is, principle that would not be rejected by people who would think, what would I accept if people who would be not motivated to not find principle, and so on, right? So you can see that's why there's this circularity thing, right? It's a recursive idea, okay? So what you ought to do in Scanlon principle, in Scanlon view, right, is to do things that would not be rejected by anyone who's motivating to find principle, which could not be rejected by anyone who's motivated to find principle that could not be, and so on, right? Okay, yeah?
But these people are probably philosophers, so you just define philosophy.
Well, I mean, not necessarily, right? So at least Scanlon is going at great lengths to claim that this is not the case, right? This is not only the wise philosophers who went to his lecture that should actually. He says there's this general intuitive idea which are reasonable rejection criteria that I sort of share. Of course, there's a component of relativism in this idea because this will be relative to a community of actors or of people, right? Okay, and that's important, right, for him. But he says he's confident that as the community goes bigger, there's still some hope that we can find principle that no one could reasonably reject, right? On this idea of intuitive idea of what reasonable is, yeah.
The general principles which could not be rejected by others on the same grounds would be those when my own maxims, I'm right now discussing the categorical imperative of Immanuel Kant.
Very good.
And that is the most simplest thing to describe this situation.
I
ought never to act except in such a manner that my maxims should become universal.
Right, okay, so very good. So Kant is sometimes seen as one of the early version of what's called modern contractualism, and Scanlon is one obviously one modern contractualism. So morality is defined as some type of generalization principle, and of course this is implicit going on here, right? But in the relation between the categorical imperative in each of these forms, because as you know, so Kant gives three formulations of this, right? Some of them are closer to Scanlon principle, some of them are less close. This has been also discussed in details by philosophers. This is a subtle issue, right? But indeed, at first sight, this looks very similar, but Kant's universalization criteria is slightly different because there's no real agreement. So this idea of agreeing in Kant is not very there, right? It's about what would happen if everyone would act on this maxim, right? And here it's about reasons that you use to convince other, right? It's really about the reasons that you put on the table in discussion.
See, the general principles could only be those principles which are, I don't know their validity as such in truth or falsity, but the one which are mostly acceptable. The generalization itself means that mostly acceptable.
Right. So those would pass the test, right? But one claim of Scanlon is that there's more.
80% people wanting a corrupt government, that does not justify corruption, but it kind of proves that this is what people want.
Yes, but it doesn't justify it in this sense, right? Because if you're someone who's being passed by the corruption, right? If you don't have the mean to enter the corruption game, right? Then I could not justify corruption on these grounds to you, right? Everybody does it, you'll say yes, but I'm still worse off in this case, right? Okay, so this would not pass this test, right? Yeah. Okay, so as I said, so what we owe to each other is one of the most influential, or at least most widely discussed book in ethics, in contemporary ethics. All aspects, each of its page has been discussed. But one which has less been discussed is the recursive character of the definition of right and wrong, right? And what I mean by recursive is precisely this sort of infinite loop that I was entering earlier, right? So I should, an act is wrong, right, if it could be rejected by someone who's motivated to find principles which, and then here's a recursion start, right, would not be rejected by people who, et cetera, right? So there's a recursive character to it, right? And some philosophers have flagged a bit, some worried about, yeah, maybe this is circular, maybe this is empty, right? But not very much. And of course, as logicians, we're not afraid of circularities, right? We know that not all circles are vicious. And so the question is this a well-founded circularity? Does it have a fixed point, this recursive definition, or is it something which would go on forever, which has which doesn't terminate, right? And that's the goal of the rest of the investigation, which I can only sketch to you right now. So then what I will say is I'll tell you what we do with the tools that I'll present you, and then I'll present you the tool that's going to be over. So what we do is that we try to capture Scanlon criteria in a language, a modal language, which is equipped with fixed point operator, right? It's called a modal mu calculus. I'll present you it in a minute, okay? Now, one feature of the modal mu calculus is that it makes some restriction of the formula in such a way that you know that these formulas or this operator that you're defining will have fixed point, right? You're restricting yourself in technical terms to monotone function, which we know by Tarski's fixed point theorem have a fixed point. So the exercise here is, actually, if we can write down a formula in this calculus which plausibly capture Scanlon idea, we already make a good way because we've shown that by the property of this calculus, this formula is an operator which has a fixed point, so the recursion is actually not circular. At some point, we reach a point where we can say yes or no whether a norm is justified or not. And that's the goal of the exercise. And for that, I refer you to see how this works. I refer you to the paper that I think I passed to Sujata. One of the paper I passed to you is the paper where we describe how we do this. Okay, so yeah. All right, so then I'm going to finish by giving you a 15-minute crash course on the modal mu calculus. This is something everyone should know and love, right? And I've been pressed on multi-agent all the time, so there's finally going to be games and people multi-agent, so this is going to be the multi-agent finishing touch. If you want to know about the mu calculus, I can highly recommend Edith Enema's online lecture on the mu calculus. This is what I will say is mostly based on. This is available online. The address is here. And did I send it to you, Sujata? No? Okay. Then, but the slides are available. Yeah, these. What? Edith. Well, they're on the web page of a course he taught previously. So I think if you go to his web page, it's not entirely obvious, right? But if you Google Edith Enema lecture notes on the modal mu calculus, you find it, right? And Google is smart enough; it recognizes mu as mu, so you can write it in English, and it works, right? Okay. So this is great lecture notes. I mean, they're unfinished at some points, but really it gives you the very good description of what's going on. Okay. So this is our clumsy, terrible language that we use in the paper, but now we're going to forget about this part here. And just think of the mu calculus as a propositional language with some modal operator. In this case, they're a belief operator, right? But that's for the reason that are in the paper. And there's two, well, you can actually just use one, but for simplicity, let's use two. We have two fixed point operators, right? And three variables, okay, that you can apply to formula. So if phi is a formula, you can replace some of these sub-formula, I'll tell you how it goes in a minute, by some variables and form the formula mu x phi x, right, okay. So mu x intuitively says the fixed point, the smallest fixed point of the formula phi, and this says the largest fixed point, or the greatest fixed point of the formula phi, okay. So that's the language we're going to be working with. One important restriction that the mu calculus does, or that you do when you work in the mu calculus, is that you require all the variables to be positive. That is, to be in the scope of an even number of negation. Okay. And that's important because it ensures that these formulas with a free variable x will turn into monotonic operators, as I said earlier, and this will ensure that they are fixed point. Okay? No, there's no quantifiers. This is, you'll see how this works. These are variable for propositional letters, right? This is essentially what they are, right? So there's no quantifier. So this is fixed point operators, right? Okay. So here's a typical fixed point formula that you can construct, right? Mu x, I believes that P n x. Okay, right? So that's a typical well-formed formula, right? And you can see that the x here, the free variable x, is taking the place of one formula in this language, right? So you see this is not a quantifier, right? This is a placeholder for a formula, okay? Now, how to... Yes, you can think of it. You can think of it this way, although they never get replaced, right? Okay, but in the models, they work as they range. You can think of them as proposition, right? So you vary the extension of this variable by changing the assignment, right? And you assign them set of the set of states, subsets of your set of states. Sorry, and these are propositions, right? Okay, so you can think of them as formula, right? But they need not to be definable. So there's some subtleties here, right? Okay. So a formula like this, right, how should you read this, right? Well, you should read this as I believe that P and that very formula, right? Okay, so it's a recursive thing that brings you back to where you were. So when you unpack it, right, you say, I believe that P and, I believe that P and, I believe that P, and so on, right? So you repeat as you unpack the formula, you just keep going, right? Or if you want to think of it syntactically, right, the fixed point of your formula is the phi such that when you plug it in, you get it out, right? Okay, that's just what the fixed point is, right? So if you're familiar with intuitionistic logic, for example, there's a lot of fixed point theorem, and you prove syntactically that these guys exist. Now, once you have this, right, you can think of a mu operator as describing the smallest fixed point, which in syntactical term would be the logically strongest formula, right? The one that implies all other fixed points, and the nu operator as describing the logically weakest formula, the one which is implied by all the fixed points. Okay, and again, since this is the monotone operator, we not only know that largest and smallest fixed point exists, we know actually that the set of fixed points of this operator's formula is, right? And that's very important for this. Okay. Good. So semantics, how does this work? I just want to sketch you how this works because it's such a nice thing. So there's a set theoretic semantic for the mu calculus, which indeed computes largest and smallest fixed point of some operator, but it's, at least for mortals like me, it's pretty complicated, right? So I look at it, I have a hard time understanding it, right? But there's a very natural semantics for the mu calculus in terms of games. Right. Okay, so the game theoretic semantic is surprisingly simple and surprisingly natural. So this is what I will present you now, right? And by the way of doing this, I'll tell you how to do game theoretic semantic in general for model formula. Okay, so we're going to interpret formulas by playing a game. Right? So a game is a game as our little game. Whoops. Everything all right? Yeah. Okay, so there's two players in this game. There's Abelard and Eloise. Okay? And each player has, and this is just for memory, can have different roles. They can be verifier or falsifier. Okay? Now, the game starts always by Abelard being the falsifier and Eloise being the verifier. Okay. Now, if you know game theoretical semantic, you might not be familiar with this verifier-falsifier thing. It's because you can actually do away with it, but just to understand the thing, how this works, this is actually very helpful. Okay. So if the formula you're interested in is a conjunction that we evaluate in a model, a Kripke model like we had before, right, yesterday, right? If it's a conjunction, what happens? Well, the choice is for falsifier, which at the beginning of the game is Abelard, right? And Abelard chooses between one of the conjuncts, and the game continues, right? So we continue the game on the same model and the same world, but on phi, or the same model at the same world, but on psi, right? So you can think of Abelard or falsifier as trying to show that the formula is false, right? And he picks a conjunct, right? And he claims this one is false, right? And he tries to force Eloise or verifier to into a place where she cannot do anything anymore. Okay? So that's a clause for conjunction. The clause for disjunction is actually completely mirroring, right? So if we have a disjunction, then this time it's Eloise or verifier that's to choose, and she chooses a disjunct, right? And the game continues on that. And that's how the game goes for disjunction, right? And again, so Eloise tries to show that the formula is true. If it's a disjunction, she only has to choose one of them, right? So if she manages to show that one of them is true, then she wins. Right? Okay, that's good. Negation is a role switch. And this is where these verifier, falsifier are actually good, right? So suppose we start the game, so verifier is Eloise is verifier and Abelard is falsifier. If we enter a negation, what we do is that we continue on phi, right? Except that we switch roles. Abelard becomes verifier, and Eloise becomes falsifier. Okay? And all the rules, these two rules that I gave you before, right? The choice is assigned to the role, right? Okay? So from now on, until we hit another negation, Abelard will choose the disjunction, and Eloise will choose on the conjunctions. Okay? So we switch role. Right? Okay? Good. Belief modality does precisely what you would expect, right? So if you you can think of it as a universal quantifier again, if it's a box, right? Okay. So, and a universal quantifier are sort of big conjunction, right? Okay. So it's a choice for falsifier, choose one possible worlds, move to there, right? Okay. But we don't have much time, so I'll just show you an example in a minute. I want to show you this one, which is that's the nicest one. Okay. So what do you do when you're hitting a mu formula? Well, nothing for now on, okay? So what you do is, so suppose we're here, we have Eloise and Abelard. What you do is you just keep going. This is the next, right? Yeah. Okay, so you keep playing, right? On phi, banking the same role. Right. So you play phi, whatever phi it is, right? Okay, right? Until you hit the x, right? Okay. And so if at some point you reach this point where you hit the x, which is inside the formula, right? What do? Well, you start all over again, right? So G and W phi x. And the game keeps going. Okay? Right? So now you see, this can be an infinite game, right? Because this can circle, right? Okay, so because what actually this is doing is bring you back out there, right? Okay. So if we enter a mu formula, we keep playing until we hit the free variable. And then when we hit the free variable, what we do is that we come back to the formula that was in the scope of the mu operator, and we keep going. Okay? All right. Okay. Now, what you need to know about that is when do a player win? Well, you win, and you have two conditions. Yeah?
You didn't say pose verifier.
Ah, well, it depends, right? Okay. Well, if in the mu calculus, I remember this guy here has to be within an even scope of an even number of negation, right? This means that by the time we've reached the x, we will be back at this configuration, right? Okay, that's the whole point of it. That when you never flip roles when you're unpacking, right? Okay. So the winning condition, where if you hit a propositional letter, right, then there's nothing to do. The player whose verifier win if the proposition is true in this state in that model, and he lose or she lose, depending on who's verifier at that point, right, if the proposition is false. Okay, that's very simple. Right, so that's the point where the game ends. But it could be that the game is not ending, right? Okay, so if we hit an infinite branch, and what happened in this case? Well, if it's a mu operator, Eloise wins if this variable is unpacked, that is, we pass through this only finitely often, right? And if it's a new operator, this other one, the greatest fixed point, then if this is unpacked infinitely often, then Eloise wins on that branch. Okay? So these are the winning conditions in case we hit an infinite branch, and otherwise we hit a proposition and we're done. Okay? So just to give you a little intuition of how this goes, right? So you can ask yourself, well, suppose we have this little model, right? Okay, so this is a Kripke model for our belief modality, right? This is our relation, and there's only one agent, okay? Now, let's take a non-model formula first, right? Mu x px, right? Is this true at W1? You don't even have to play the game, right? For computing non-model formula, it's much easier to think about the syntactic way of computing fixed point. You remember I told you a fixed point is the phi such that, let's say in this case, right, phi is equivalent to p and phi, right? Okay? And mu is the smallest, the logically strongest proposition that has this property. What's the logically strongest proposition ever? False. Excellent, right? Falsum is the logically strongest proposition. It implies all others, right? Okay. What happens if you plug falsum in there? What do you get? You get falsum back, right? Indeed. So that's a fixed point, and that's the smallest fixed point. Okay? So we have it. So the smallest fixed point of this formula is falsum, but a score falsum is true nowhere, right? So this formula is false at W1. Okay? Right? Now what about this? The smallest fixed point of P or X. P, right? Okay? P or P returns you P, right? And strongest proposition, I mean, these are atoms, so the only stronger would be falsum, right? Okay, so P or, well, you can have infinitely, well, in this case, there's no other proposition, right? So P or P returns P, right? And that's a fixed point, and that's indeed, in this case, a false fixed point. But at W1, W is not in this fixed point, so that's false. Okay? Right? Good. Now what about this one? Mu x P or X with a belief in front of it, right? And there you can play the game. Let's play it very quickly. So you start here, right? It's a mu operator, so you don't do nothing. You move one step further. You hit the belief operator. I mentioned that this is a choice for falsifier, which is Abelard. Abelard chooses a state. He's got to move here or there, right? Okay. But then it's a disjunction, and it's Eloise to choose. You can choose to move to P or to X. But of course, wherever Abelard goes, it's a P world, so she will always win by choosing a P, right? So this is true. Okay, right. So this one we didn't have to unpack, right? It was just a normal model operator. So I just meant.
What is the formula that you can plug in there?
In this case, well, in this model, well, basically, this formula is true everywhere, right? Okay, so the greatest. Let me think about it. The greatest fixed point is certainly So in this case, I think it would be the tautology, right? Yeah. Yeah, so that's both. There's this formula has a unique greatest and smallest fixed point, actually. Yeah. Good. All right. So let me mention you a few things about the mu calculus. It's a very nice extension of modal logic in the sense that it has very nice computational property. At least for the basic model language, it has a finite model property, which is pretty surprising given its expressive power. It can express things that go way beyond the expressive power of ordinary modal logic. For instance, it can express notions like safety and liveliness if you're interested in verification of protocols. So that's actually very good. And in this case, it got this recursive character, which is interesting for capturing this notion of justification of norms that I was mentioning at the beginning of this part, right? So this is the complicated formula that we use in the paper, which has a lot of very nice property, but then I refer you to the paper to that. I just want to finish by sort of calling for if people are interested. So actually, this is very new work, and there's a lot of questions that we are not answered about this. For example, we know that the mu calculus is completely axiomatizable. It has a finite model property, but we don't know with this all the operator that we use in this language, and particularly for the assumptions we made on these modalities. There's an interesting question regarding to whether we can compute fixed point of these formula, because remember they correspond in our framework to the idea that a norm is justified, and there's interesting epistemological aspect to it. But this is all in the paper, so I will not bother you with this. I just want to finish by 2 minutes. Sorry, I know we're late, but 2 minutes by just wrapping up and telling you what we've been doing, right? Okay, so I started by presenting you standard Deontic logic. And I mentioned it, and I will mention it again. Standard Deontic logic is the point of reference that everybody, or most people use in Deontic logic nowadays to situate themselves, okay, to say how the system that you develop differ from standard Deontic logic. And the reason for that is that, as you've seen, standard Deontic logic is a nice, well-known modal logic, but when you think about reasoning about norms, it has many limitations, right? It doesn't deal well with free choice. It doesn't deal well with conditional obligations, which are two major issues, and there are others, right? A lot of other Deontic paradoxes, right? So standard Deontic is important, but it's a point of departure, okay? And nowadays, issues that are highly discussed are indeed notion of permissions, free choice in linguistics, and also in philosophy, notions of conditional obligations and defeasible obligation. This is more in computer science and theory of non-monophonic reasoning, and normative conflict in philosophy, but also in computer science, because you want to be able to reason with possibly inconsistent database of obligation, right, or legal system we were talking about, which are not necessarily consistent. And these are arguably some of the most active field in Deontic logic nowadays. And it's still very active, so there's still a lot to do and a lot of questions to ask in each of them. So on that, I'd like to thank you. And hope you're going to do Deontic logic.